Hi guys, my name is Mr. Nyalungu FI. Today's lesson it's about engineering science N3, so we'll be focusing on electricity. So we have a circuit on the board, a series parallel circuit. So that's what we'll be dealing with today. By looking at the circuit, you can see it has three resistors that are connected in parallel. Right? That's why you have your 4 ohm, your 3 ohm, and your 2 ohm. Now this parallel combination is connected in series with R4, right? This combination is therefore connected in series with another resistor, R5. So we can see the information on the circuit, right? So now we are asked to calculate the total resistance of the circuit and also the current flowing through the circuit, and also the voltage drop across the internal resistance of the supply voltage, right? So there is information that we are given there that is not on the circuit itself. So let's check this information so that we can add it there, right? So we are told that each cell has an EMF of 1,5 volts, right? So I believe that you know that a battery is formed by a number of cells. So you can see there that you have a battery that has 3 cells that are connected in series, right? So there you are told that the voltage drop across each cell is 1,5, right? So you will have to now calculate the total EMF. As we can see that this series parallel circuit, it has 3 resistors that are connected in parallel. Your R1, your R2, and your R3. And you can see the resistance of each resistor, right? You also have this parallel combination connected with R4, right, in series, and also R5, right? So there we are asked to calculate the total resistance of the circuit. We are also asked to calculate the current that is flowing through the circuit, that is the total current. And we are also asked to calculate the voltage drop across the internal resistance, right? Well, we have this information here. We don't have it in the circuit. As you can see there that we have a battery that consists of 3 cells. So we are told here that each cell has an EMF of 1,5. So it means that the voltage across each cell is 1,5, right? So you can clearly see that the total EMF has to be calculated there by considering the number of cells that you are given. So you are going to multiply the number of cells by the voltage across each cell, right? So we can do that using our calculator, right? So you have 3 cells multiplied by the voltage across each cell, which is 1,5. So now the total EMF is 4,55 volts. Let me say it again. We determine this value, this 4,5, by multiplying the voltage across each cell by the number of cells. So we've got 3 cells there, right? Well, if we have 3 cells and we're told that the internal resistance in each cell is 0,5, this information will assist us to calculate the total internal resistance. So we're going to do the same here. We have 3 cells. They say each cell has an internal resistance of 0,15. So we're going to say 0,15 multiplied by the number of cells. So it's 3 multiplied by 0,15. Right. So the total internal resistance now is 0,45. Now, what you must know is that the supply or the EMF is now connected in series with this internal resistance. So I will just put it here, add it in the circuit so that we are not confused. This is now our internal resistance. Remember, we've calculated it. 0.15 multiplied by the number of cells. So we are getting 0.455 ohms. So don't be confused there. The 4.5 volts, it's for the battery, right? That's what you are supplying to the circuit. The 0.45 is the internal resistance of the battery. So I did mark it in red there, you can see. So the question says, calculate the total resistance of the circuit, the current flowing through the circuit, and the voltage drop across the internal resistance. So the internal resistance is this one here, right? So the magnitude there is 0.45. So now we are going to calculate the total resistance. So to calculate this total resistance, since we are dealing with a series parallel circuit, you have to know how to deal with resistors that are connected in series, and how to deal with resistors that are connected in parallel. So if for example you have resistors that are connected in series, let's say maybe there are two, right? R1 and R2, they are in series. To calculate the total resistance between these two resistors, you are going to add their values, right? So it will be your RT if they are two and are connected in series. So you are going to say R1 plus R2. I believe we still remember that. And now, if we have these resistors R1 and R2 in parallel, your RT, if they are two, we are going to use the product over sum, where we multiply these two resistors on the numerator, and then we add them on the denominator, where you have R1 plus R2, right? So what you have to remember is that you can only do this if you are dealing with two resistors in parallel. But if you have more than two, you have to now apply the equation 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is an equation that you can use to calculate the total resistance if you have three resistors that are connected in parallel. But this equation doesn't limit you. Even if you are given two resistors, you can use it, meaning that now we can close that part, right? If you are dealing with two resistors. But this one here, it's limited. You can only apply it when you are dealing with resistors that are connected, two resistors that are connected in parallel. This one, even if you have 3 or 2, you can use it. So you can always use this one here. So to calculate the total resistance, you have to identify all the resistors that are connected across the circuit, right? So we have 3 resistors that are connected in parallel. So this parallel combination is connected in series with R4, R5, and our internal resistance of 0.45 ohm resistance. Right. So, as I've explained before, that if you have 2 or 3 resistors that are connected in parallel, you can apply this equation to calculate the total parallel resistance. So, you can see that when we are considering this circuit, this here, it will be the total parallel resistance, but not the total resistance of the circuit, because we have R4, R5, and our internal resistance. So these are external resistors. They must be added to this to get the total, right? So now, let's reduce the circuit. Our R1 has a resistance of 4 ohms, so we are going to write this as 1 over 4, plus our R2, 3 ohms, so we write this as 1 over 3, plus our R3 is 2 ohms, so it's 1 over 2. Now, what you have to remember is that you are not calculating the value of 1 over Rp. You are calculating the value of Rp. So you need to get rid of this one in the numerator, right? So I can write this as R parallel is equal to, I put this fraction inside the bracket and I introduce a -1, right? So now you can put your calculator there to get the total parallel resistance. So now the magnitude of Rp is 0.9223 ohms, right? So now you can see we have reduced the circuit. We've used R1, R2, and R3 to get 0.923. So this is the resistance of our parallel combination. So what did we say? We said the parallel combination is connected in series with R4, R5, and our internal resistance. And also remember what I said, resistors that are connected in series, I said if they are 2, it doesn't matter how many they are, but we made an example. We said if they are 2, to calculate the total series resistance, you are going to add the 2. So we are going to apply this because we are saying this parallel combination is in series with R4, R5, and our internal resistance. Right, so it means that now our RT will be equal to R parallel with the magnitude, I will write the magnitude, with a magnitude of 0.923 plus R4, which has a magnitude of 10 ohms, so it's plus 10. We also have R5, we are going to add the 1, it's plus 1. We also have our total internal resistance that was calculated, just to remind you, by multiplying the number of cells by the internal resistance of each cell, right? So we got 0.45. Now let's use our calculator to see the magnitude of the total resistance. Right, so the total resistance RT is equal to 12,373 ohms. Right, so we have answered the first question. Thank you for joining us on this lesson of calculating the total resistance. Let's meet on the next lesson where we'll be now calculating the total current. Thank you.